Hi everyone. So this is going to be some of the more trickier questions in section, well, in the section on substitution. So these come from the homework, and the first one I'll do is the integral of the seventh root of tangent of 8x times secant squared of 8x. Yeah, this is definitely one of the more difficult ones. The thing that you should remember here is that if I'm going to take the derivative of, let's say, tangent of theta, you should remember that that's just secant squared of theta, right? So we're going to use that here. Obviously, we have secant squared is the derivative of tangent. So that lets me believe that we should let our substitution, our u, just be tangent. In this case, tangent of 8x. Right? So let's see why that's the case. If I take the derivative of tangent of 8x, I get secant squared of 8x, oops, not of 8, 8x. Now, don't forget the chain rule, right? You still have to take the derivative of 8x, which is just 8, right? So this is secant squared of 8x times 8, although it would probably be more helpful to bring the 8 in front as the coefficient, right? So that's my derivative of u. Now, if I multiply by dx, I just get that du is 8 times secant squared of 8x dx, right? So now we can see what we need to do here. I guess one more thing we can do is rewrite the seventh root, right, as, let's do tangent of 8x to the power 1 over 7, right? That's the seventh root. And we have secant squared of 8x as the other factor. Okay, so there's one more issue here. It's this 8, right? There is no 8 in front of secant squared of 8x. So that's a problem, but it's one that we can easily take care of by just multiplying by 8. That's a funny looking 8, right? Now, we can't just multiply by 8 because then our answer will be, well, 8 times what the answer should be. But if I multiply by 8 and divide by 8, then we're okay because we just multiplied by, we just multiplied by 1, right? So, there we go. Right, we just multiplied by 1. 8 over 8 is 1, right? So I'm just going to take this 8 in the denominator and pull it outside as 1 over 8. Right, so everything else I think is exactly the same. Okay, so now what I can do is replace this 8 secant squared of 8x dx. That's the same as this, exactly the same thing, right? So what is this equal to? Well, it's equal to du. So I can simply replace this with du, because they're equal, right? So we still have the 1 over 8 on the outside. Again, that came from this 1 over 8 here. And we still have to multiply by the integral of tangent of 8x to the 1/7. But remember, tangent of 8x is the same as u. So this just becomes u, but to the power 1 over 7. So u to the power 1/7. Okay, so now everything is in terms of u. We have 1 over 8 times the integral of u to the power 1/7 times du. Okay, so at this stage, this should be absolutely trivial by now, at least I hope so, if you remember the power rule for integrals, right? The integral of u to the n du is just u to the power n plus 1 over n plus 1. Don't forget the c, And I should remind you that there's one exception to this, right? This works if n is not negative 1. So our n, the exponent, is not negative 1. It's 1 over 7. Okay, so here our n is just 1/7. So what's n plus 1? Looks like an h. I'll rewrite it as n plus 1. So 1 over 7 plus 1 is 1 over 7 plus 7 over 7, which is 8 over 7. Right? So when you divide by 8 over 7, you're multiplying by 7 over 8. Right? So this is still 1 over 8, right, times u to the power 8 over 7 divided by 8 over 7 plus c, or 1 over 8 times 7 over 8 times u to the 8 over 7 plus c. And now we're almost done, right? Let's just multiply these two numbers. We get 7 over 64 times u to the 8 over 7, I'll make it a little bigger, plus c. And finally, what was u? U was originally way up here on the upper right, tangent of 8x. So let's just replace u with what it was originally equal to, what we set it equal to, tangent of 8x to the power 8 over 7, and don't forget the plus c. And I think we're done. I think that's it. If you still want to put parentheses around the 8x, that's fine too. But it's the same as just tangent of 8x, right? And you should check, right? You should check by taking the derivative of this and checking to see that you get, what was it originally? All of this, the integrand. Okay. In fact, I'll leave that as an exercise, right? So take the derivative of this thing that I put in the box here. And what you should get is tangent of 8x to the 1 over 7 times secant squared of 8x, right? Which is the same thing as the 7th root of, right, tangent of 8x, oops, times secant squared of 8x. Okay, so that's what you should get if you take the derivative, again, with respect to x, right? And there's a chain rule, so don't forget the chain rule. Okay, so, right, so that was, I think, number 13 in the homework. Let's do one more. Okay, so we have the indefinite integral of negative 8x all over x plus 1 minus the square root of x plus 1 dx, right? So with respect to x. Okay, yeah, this is going to be a tricky one. And I would start with the basic rule here. What's in the parentheses or what's under the square root? They happen to be the same thing, right? They happen to be x plus 1. So let's just try u is x plus 1. Now that alone is not going to get us very far, but it's a good start, I think. So let's try that. So what's the derivative of x plus 1? Well, it's just 1 plus 0, right, which is 1. And so if I multiply by dx, that tells me that du is the same as dx. It's 1 times dx, or just dx, right? Okay, so we have negative 8 times x. Oh, what's x? So if x plus 1 is u, if I subtract 1 from both sides, x is really just u minus 1. So we have negative 8 times u minus 1 over u minus the square root of u, and then dx is the same as du. Okay. The negative 8 is just a constant. Since it's a constant, we can bring that outside. And now we have this. And as I said, this doesn't look any easier, and in fact it's not. Well, it's maybe a little bit easier, but not much. So this is where we're going to have to remember what happens when we see something like a square root in the denominator. Well, It's a trick that we've done many times with limits. Now we're going to do it with integrals as well. Right. So the standard technique here is to multiply numerator and denominator by the same thing, right? Again, we're just going to multiply by 1. That doesn't do any harm. And we're going to choose to multiply by the conjugate of the denominator. So instead of multiplying by u minus the square root of u, let's just switch the sign to u plus the square root of u. And then multiply by the exact same thing on the top. And this is still, this is still du here. Right? So all I did was multiply by 1. Right? I could cancel these, then I'm back to the previous step. Right? But you'll see in a minute why this helps. Right? So yeah, this is kind of tricky. It's the same thing we did with limits. Remember when we took limits and we had this pesky square root in the denominator? We want to rationalize the denominator. So the numerator, I'm going to leave it alone, right? You might say maybe I should, multiply this out. Just use FOIL here. You could do that, but let's wait until it's absolutely necessary. Instead, let's see what happens with the denominator now. Let's multiply that out, right? So we get u times u. That's just u squared. And then the outside, we get u times the square root of u. Right, or u to the 3/2, if you like. And on the inside, I get u times negative square root of u. And you can see that that's just going to, that these are just going to add up to 0, right? And then the last, we have a negative times a positive, so that's negative square root of u times the square root of u, but that's just u, right? Square root of u squared, the square cancels the square root. And that's just u. Okay. So, as I just indicated earlier, all of this adds up to 0. And so the denominator is just u squared minus u. Okay, that negative 8 is still there. And the numerator is u minus 1 times u plus the square root of u all over u squared minus u. And at this stage, you might be thinking I'm completely crazy because how is this any easier than the original problem? It doesn't look easier, does it? But look carefully at the denominator. The denominator, u squared minus u, should remind you of something. Right? There's a factor of u in each of these. So I can just factor out a u. And if I do that, I get u minus 1. Aha! Now you see the method to my madness here, right? That was the whole reason for multiplying by this weird conjugate thing, right? So u minus 1, there's a factor of that in the numerator, and there's a factor of that in the denominator, right? It's like 3 divided by 3. It's just 1, right? They cancel. Okay, so with that, what does this become? We still have the negative 8. That's not going anywhere anytime soon. The numerator is just u plus the square root of u. Oh, at this point, we know the square root of u is also u to the power 1/2. The denominator is just u. Right. Now I think we're making pretty good progress here, because the denominator is just one term, it's u. So when you're adding up two things in the numerator, you can just split apart the two fractions, right? This is u divided by u plus u to the 1/2 divided by u. Right? If you don't believe me, just add these two fractions. They already have a common denominator. You just add the two numerators, and you're going backwards, right? So why would I want to split this up? Well, u divided by u is 1. And u to the 1/2 over u is u to the power, remember your rules of exponents, 1/2 minus 1, right? Which is just u to the negative 1/2. So this is going to be negative 8 times the integral of 1 plus u to the negative 1/2. Okay, now we're good, right? We're just going to use the sum rule here. This is the integral of 1 du, plus the integral of u to the negative 1/2 du. And that's just going to be negative 8 times the integral of 1 is u. The integral of u to the negative 1/2, well, that's the power rule, right? You get negative 1/2 plus 1 is just positive 1/2 divided by 1/2. But if you divide by 1/2, you're just multiplying by 2. Right. Now, at this stage, we took the integral already, right? So don't forget the plus c because it's an indefinite integral. And now just distribute the negative 8, right? So we're going to get negative 8 times u plus negative 8 times 2. So that's negative 16 times u to the 1/2. And then minus 8 times c, but that's still just a constant, right? Let's just call it c. Let's say capital C, right? So there you have it. I'm running out of space here, so I guess that's our answer to the original problem. Yep, negative 8u minus 16, well, u to the 1/2 or just square root of u, right? We can leave it like that. Right, so that's the answer to all of this. Negative 8 times u minus 16 times the square root of u plus c. But we're still not quite done, are we? Remember what u is. U was defined to be x plus 1, so we have to go back to x. Change u to x plus 1. So we have negative 8 times x plus 1 minus 16 times the square root of x plus 1 plus c. Right, and that's good enough. We can even go a little bit further here, right? This is negative 8 plus, negative 8x minus 8 minus the square root of 16 times, minus 16 times the square root of x plus 1 plus c. Let me say that again because I think I went a little fast there. Negative 8x, right? That's negative 8 times x. And then negative 8 times 1 is this negative 8 here, right? So I just distributed the negative 8. Yes, please do not distribute the negative 16. That does not work inside the square root, right? Okay, now this negative 8 is really just a constant. This c can absorb that. So even though you don't have to do this, this is really just negative 8x minus 16 times the square root of x plus 1 plus c, a different c here. So you can call it c2 if you like, or c prime or something. Or not prime because that's, whatever. It's a different c. It's a different c than this, right? Right, right, because this is literally c minus 8 instead of c. All right, so this is probably the best way to write the answer. Again, if you left it like this, that's okay too. Just be aware that if the book has this answer and you have this answer here, you're saying, wait a minute, I have x plus 1, the book only has x, I must be wrong. No, you're not wrong. You just have a different c than the book. Your c is c minus 8, and their c includes the negative 8. That's the only difference. Okay, so like I say, that was a long and tricky one. It involved this conjugate thing here. And in fairness, we could have done the conjugate right away in terms of x. We didn't need to substitute u as x plus 1 here. I just did that to make this look a little bit easier than the original problem. Yeah. All right, so that was a hard one, and that's why I did it. All right, so let's move on to another one. Okay, and I think this will be the last one. This I'm just pulling right out of WebAssign, if that's okay. So the questions, and I forgot which one it is. It's one of the last 2 or 3, right? Right, and I know the text is a little bit small, so I'll try to read this carefully. It says the rate of depreciation, dv over dt, of a machine is inversely proportional to the square of t plus 1, where v is the value of the machine t years after it was purchased. The initial value of the machine was $700,000, and its value decreased $100,000 in the first year. Estimate its value after 4 years, and then round your answer to the nearest whole number, so nearest integer. Okay, so where do we begin? Okay, so what they are saying here, this first statement, the rate of depreciation, right? So this is dv over dt. They are giving us the derivative, right? Anytime they use the word rate, think derivative, right? Rate of change. Okay, so the rate of change of the value, that's called the depreciation, is inversely proportional. So when they say proportional, there's some constant k here. We could use c, but remember there might be a plus c at the end, and that might be a different c. So I'll use k as the constant of proportionality. So inversely proportional. So inverse means we're dividing by the square of t plus 1. So here's t plus 1, and that's the square of it. Okay, so the derivative of v is inversely proportional, right? So it's going to be k times 1 over t plus 1 squared. So I think that's fine. Let me just make that a little bit more clear, right? So this is k divided by, let me make my k look like that. K divided by t plus 1 squared. Okay, what else do we know, right? So we're looking for the value of the machine t years after it was purchased, right? So if you know the derivative and you want to find v, you're going to have to find an antiderivative, right? But what else do we know? We know that the initial value was $700,000. So the initial value is the value at time t equals 0. Right? That was when we bought the machine, essentially. That was when it was purchased. So the value originally, after 0 years, was $700,000. We know this is all in dollars, so we can dispense with the dollar symbol. Yeah, so this is what we know, right? So again, the question is, how do we find the value after t years? And in particular, then, we need the value after 4 years, right? So what we want to find is v evaluated after 4 years. So the way we're going to do that is, first we're going to find the value after t years, any number of years, and then we can just plug in 4 for t. Okay? So that's our goal, right? So how do we find v of t? V is the value of t. We're going to have to integrate the derivative, right? So when we integrate the derivative, that just gets you the original function v back. Okay? So, and we know what the derivative is. It was given as k over t plus 1 quantity squared. And then we're going to integrate with respect to t, right? That's the variable here. K is a constant, so that can come outside. Right. And then this is just 1 over t plus 1 squared dt. Or, maybe better yet, right, we can write this as t plus 1 to the negative 2 instead of 1 over t plus 1 squared. So we're going to use the power rule. Now, before we can do that, we do have to make a substitution, right? We know how to integrate, let's say, u to the negative 2 using the power rule, but we don't know how to integrate t plus 1 to the negative 2. So that tells me yet again that we need to make a substitution. So let's let u just be what's inside the parentheses, t plus 1. So that the derivative of u is just 1, and if you multiply by dt, du is the same as dt. Du equals dt, right? So this becomes k times the integral of u to the negative 2 du, because remember dt equals du. Right? So yeah, here there's nothing we have to multiply by or divide by, like in our first problem. Okay, now just apply the power rule. Right? And here it is again, just to remind you, u to the n with respect to u. This is just going to be u to the n plus 1 over n plus 1 plus c. Don't forget the exception, right? N cannot be negative 1. What is the n in this case? It's the exponent, negative 2. Okay, so negative 2 is not negative 1, so we're okay. We can apply the power rule here. Right? So the integral of u to the negative 2 with respect to u is just u to the negative 2 plus 1 divided by negative 2 plus 1. And negative 2 plus 1 is just negative 1. So u to the negative 1 divided by negative 1, or just negative 1 over u plus c. Okay, so this is going to be k times negative 1 over u plus c, or negative k over u plus c. Okay. All right, so that's v of t. Except, wait a minute, where's t? Right? There's a k, there's a u, there's a c, but there's no t here. So how is this a function of t? It's not. We have to replace u with what it was originally designated to be, t plus 1. So this is negative k over t plus 1 plus c. Okay, so that is our function. This gives us the value of the machine t years after it was purchased. Okay. So very important. Now, of course, that's not the answer because we have to plug in 4 for t. But you can see before we do that, we have to figure out what k is and what c is. Okay, so let's see. What do we know? We know that the original value, v of 0, is 700,000. So if we replace if we replace t with 0, we should get 700,000. Okay, so let's do that. If t is 0, we get negative k over 0 plus 1 plus c, and that has to be $700,000, right? Now, this is why we needed the t plus 1, right? We're not dividing by 0, right? We're dividing by 1. So this is just negative k divided by 1, or just negative k plus c equals 700,000. Now, that's a problem here because that doesn't tell us what c is, and it doesn't tell us what k is. Okay, so this alone is not enough information to find either c or k. So that's tricky. Let's go back to the original problem. Again, the rate of depreciation, we got that. The initial value was 700,000. Oh, there's one thing we didn't use here. Its value decreased $100,000 in the first year. Okay, that is also a clue here. So what does that mean? If it decreased 100,000, that means from 700,000, if you decrease that by 100,000, you get 600,000, right, after 1 year. In other words, v of 1 should be 600,000, right? So after 1 year, the machine is worth $600,000, right? Now, I can see some of you might be thinking, wait a minute, if it decreased 100,000, isn't it worth 100,000? It doesn't say it decreased to 100,000. It looks like, and I know this is a little bit ambiguous here. I read this as it decreased by $100,000. That means the amount of decrease is 100,000. So if it decreased $100,000, its new value is $100,000 less than the original amount, which is the 700,000. So 700,000 minus 100,000 is the 600,000. Okay, if it said it decreased to $100,000, then V of 1 would be 100,000. But that's not how I interpret that. So I think this is correct. V of 1 is 600,000. So yeah, we have to use that as well. V of 1, so after 1 year we have 600,000. Okay, so if I replace t with 1, I get negative k over 1 plus 1 plus c equals 600,000. Well, 1 plus 1 is 2, right? So this is just negative k divided by 2 plus c equals 600,000. So again, this alone doesn't tell us what c is or what k is. Right? But notice now we have two equations, one up here and one down here, in two variables. Okay, so I think you know by now how to solve a system of two equations in two variables. Let me just write them down here, right? Now, I'm calling c and k variables, even though they're really just constants. We just don't know what they are yet. So here are the two equations in the two variables c and k. So you can solve this any way you want. I look at this and say, well, we can cancel the c's if we just subtract the two equations. And usually I would just multiply by -1 first. So if we multiply the first equation by -1, what do we get? We get k minus c equals -700,000. And if I leave the bottom equation alone, negative k over 2 plus c equals 600,000. If we just add those equations together, I get 1 minus 1/2, right, is 1/2 k, so k over 2, plus negative c plus c is 0, equals negative 700,000 plus 600,000 is negative 100,000. So k over 2 is negative 100,000. If I just multiply both sides by 2, I get that k is negative 200,000. Okay, so now we know what k is, and now I think we know what c is as well, right? Just go back to the first equation, negative k plus c equals 700,000. But now we know what k is. It's negative 200,000. Right? So negative minus a negative is positive 200,000 plus c equals 700,000. So just subtract off the 200,000 from both sides. So c is, it looks like 500,000, $500,000. Okay, now we know what k is and we know what c is. So now we just go back to, let's see, v of t, which was negative k over t plus 1 plus c. Okay. So just change k to negative 200,000. So it's going to be, minus a negative, so positive 200,000 all over t plus 1 plus c. C is 500,000. Okay. This is the complete value of the machine after t years. Right? And before we answer the question, right, originally we want to plug in 4 for t. Before we do that, though, here's what we probably should do. We should check that this works here. And the way I'm going to check this is the following. What is v of 0? What was the initial value of the machine? If I replace t with 0, I get 200,000 divided by 0 plus 1 plus 500,000. So that's 200,000 plus 500,000 is 700,000. And that is the initial value. Right? That was, that was the initial value of the machine. That was given. So that works out. How about the value after 1 year? If I replace t with 1, I get 200,000 divided by 1 plus 1 plus 500,000. Oops, that's a 5, not an S. Right. Now, 1 plus 1 is 2, so 200,000 divided by 2 is 100,000 plus 500,000, and that's 600,000. So that's the value after 1 year, and that's what it means when the value decreases $100,000 after the first year. 700 minus 600. Right, or 700 minus 100 is 600,000. Right? So that works out as well. Okay, so now we can finally answer the question, what was V, what is the value of the machine after 4 years? So now just replace T with 4. We have 200,000 divided by 4 plus 1 plus 500,000. Okay, so this is 200,000 divided by 5 plus 500,000. And 200,000 divided by 5, I believe, is 40,000 plus 500,000 gives us a grand total of, in dollars, $540,000. So the machine originally costed $700,000. After 1 year, its value decreased to $600,000. And after 3 more years, the value decreased, looks like, by another $60,000. So yes, the value is decreasing over time. That's what we mean by the word depreciation, right? The rate of depreciation, dv over dt, right, is how quickly the value of the machine is decreasing. Right? And it's not a constant rate. It's not decreasing $100,000 every year. Right? If that were the case, after 4 years, it would decrease by 400,000, which would only mean from 700 minus 400, it would only be worth $300,000. Okay, so yes, this is not a linear depreciation. Right? Its value doesn't go down in a straight line. If you were to graph this function, the graph would look probably something like this. It's decreasing quickly at first, but then it decreases more and more slowly over time. So that's something you should probably do is, right, graph V in terms of t here, right? Or even the derivative of V. Right? The rate is also, I believe, decreasing, but probably not quite as much. Anyways, so that's the answer to the question. $540,000 is the value after 4 years. Oops. Dollars. 540,000. Okay. Right. Again, not an easy one. It's one that you have to read the problem carefully, use all the information given. In fact, we needed 2 pieces of information. We need the value after 0 years, the initial value, and then it's the initial value, and then the value after 1 year. And the reason why we needed both of those values is because there's 2 constants, right? There's the constant of proportionality, k, and then there's the constant of integration, c. So because there's 2 constants, we needed 2 pieces of information to find both c and k. Okay. So I hope this helps a little bit going through some of the more difficult problems in the homework.